Now let's talk a bit about IPv4 addresses. An IPv4 address is a 32-bit logical address assigned to a network device. Stress on the word logical. And that's because we can configure any IP address on any device. Of course, that's not completely true. There are restrictions on what IP address we can configure. But as long as you stay within the allowed range of IP addresses, you can configure any IP address on any interface, which is why we call it as a logical address. We can decide what IP address we want to configure on an interface. It is not hard-coded on the device like a MAC address is. An IPv4 address is written in decimal format with 4 octets separated by dots. An example is 192.168.1.1. Every number that you see in the address can be represented by 8 binary bits, hence we call it as an octet. So we have 4 octets. Each octet can be represented by 8 binary bits, so we have a 32-bit address. When we say 32-bit, there are 32 binary bits in there, and we know that every binary bit can have a 0 or a 1. So that's why the total number of possible IP addresses is 2 power 32. An important thing to keep in mind is that not all IP addresses are usable or routable over the internet. There are limitations, or I should say there are restrictions on what IP addresses can be configured on the devices. IP addresses are divided into 5 classes. The first one is called Class A, and the range for that is 0000 to 127.255.255.255. Next, we have Class B, which starts from 128.0.0.0 to 191.255.255.255. Next, we have Class C, which starts from 192.0.0.0 to 223.255.255.255. Next, we have Class D, which starts with 224.0.0.0 to 239.255.255.255. The entire Class D range is reserved for multicast purposes. And the last one is Class E, which starts from 240.0.0.0 to 255.255.255.255. The whole of Class E is reserved for experimental purposes. So if you want to assign an IP address to a device, you would have to choose from Class A, Class B, or Class C. Now within each of these classes, we have some IP addresses that are reserved. We'll talk about that in the next slide. If you're wondering why we stop at 255.255.255.255, remember the IP address is a 32-bit address and it's binary bits, so it can only have zeros or ones. The least possible value is when you substitute all the bits as zeros, and that will give you 0000, which is the first and the lowest address. If you substitute the bits with ones, you would get the highest possible value, which is 255.255.255.255. If that does not make sense to you right now, don't worry, we have a lecture coming up where we'll talk about decimal to binary conversion, and there we'll understand how 255 represents all ones. Okay, so the important thing to keep in mind is that we have 5 classes of IP addresses, and each class has a specific range allocated to it. Now there are specific addresses which are called as RFC 1918 addresses. So in each class A, B, and C, a block of IP addresses has been reserved as private IP addresses. These addresses are not routable over the internet, hence they are known as private IP addresses. Now you might be wondering, what happens if I try to route a packet over the internet by assigning a private IP address? Well, in that case, you could configure a device with a private IP address and try to send a packet over the internet, but your internet service provider or your ISP will drop that packet. So RFC 1918 addresses are private IP addresses. They are called private because you can use it within your organization or within your private setup, but you will not be able to use these addresses to route packets over the internet. These addresses can be used by anyone. Nobody owns these IP addresses. Unlike public IP addresses that you purchase, private IP addresses are free for anyone to use. RFC 1918 addresses help to conserve the IP address space by allowing organizations to use these private IP addresses for internal addressing. Now think about this. If we did not have RFC 1918 addresses, if we did not have these private IP addresses, every device that is trying to connect on the internet would require a public IP address. And as we've already seen, we only have so many addresses. We only have 0000 to all 255s. And within that range, we have two classes which are reserved, Class D and Class E. So we're only left with Class A, B, and C, which is not a lot of IP addresses compared to the number of devices that we connect today. So these private IP addresses help us solve the problem of not having enough public IP addresses. Anybody can use them. So what are these IP addresses? Within Class A, the range 10.0.0.0 to 10.255.255.255 is reserved as a private IP address range. This can also be denoted as 10.0.0.0/8. In the upcoming lecture, we'll talk about what a subnet mask is, and then you should be able to understand what the notation means 10.0.0.0/8. In Class B, the reserved range is 172.16.0.0 to 172.31.255.255. This can also be denoted as 172.16.0.0/12. And in Class C, the reserved range is 192.168.0.0 to 192.168.255.255. This can be denoted as 192.168.0.0/16. From the JNCIA examination perspective, you do not have to memorize these IP address ranges, but as a network engineer, it is important that you know these ranges. This could come up in any interview as well. So make sure you know these RFC 1918 ranges. Next, we have loopback addresses. The entire 127.0.0.0/8 address block is reserved as a loopback address range. This means it cannot be assigned to a device. These addresses are called as loopback addresses, and out of that entire range, the most commonly used loopback address is 127.0.0.1. This address is also known as localhost. It is your own IP address, meaning 127.0.0.1 represents the device itself. When you send a packet to a loopback address, it is received by the same host. So if you go to the terminal of your device and if you try ping 127.0.0.1, you will get a response back because you are trying to ping your own device. So the important takeaways from this video are the classes of IP addresses, their ranges, and the ranges for the RFC 1918 addresses and the loopback address range.